I welcome everyone on this occasion of this week is a newborn care week, and recently we observed the World Prematurity Day as well. And we all kind of a day-to-day practice face a lot of dilemmas. One of which has been the feeding, and the feeding tolerance is a major concern that we all have. In this regard, path-breaking research has been done by our guest speaker today. It's my privilege to introduce to you Dr. Sanjay Patole. I'm sure we all have, we all know him as well as read the papers. So he's a clinical professor at the University of Western Australia, a neonatologist at KM Hospital for Women, Perth. Of course, the publications, plenty of them, and a very high H index, 38, and has been instrumental in, path-breaking research, and he's in the top 1% of academic neonatologists around the world. His research focus has been neonatal nutrition, prevention of NEC, probiotic supplementation for preterm infants. He's the author. He has authored books like Nutrition for Preterm Unit, a clinical perspective. And very interestingly, I wasn't aware of this, which I will definitely would like to read, is the Essentials of Leadership and Management for Hospital Staff. That would be very interesting for us as well. And Principles and Practice of Systematic Reviews and Meta-Analysis. We welcome you, Dr. Patole, and could you please go through, this presentation, please. Thank you so much for accepting our invitation. Thank you.
Thank you, Dr. Praveen. Before I start, I just want to sincerely thank everyone in the NGO Care Network team, including Dr. Datta, yourself, Rahul, and Dr. Sonam, and everyone to make this possible to have me on your forum. So that's my sincere gratitude to you. Okay, so we'll go straight to the slide for number one. Basically, when the talk is about probiotics and prebiotics, I've just chosen to go first with the human milk oligosaccharides, which are closely related to prebiotic oligosaccharides, because when we use the term prebiotics, we do not necessarily mean the oligosaccharides actually naturally present in the milk. So just to cover the basics of human milk oligosaccharide, as we call them HMOs, everyone knows they are the most complex carbohydrates, and they have basically right up to 1/3 of the component of the solid component that you see in the milk, anywhere between 5 to 20 grams per liter of breast milk. And they come after lactose and lipids as the major components of the milk as such. What they have is a single glucose molecule, and at the other end, there's a galactose, fucose, or sialyl element attached to it. And this is the complex nature which has been very difficult to synthesize in the laboratory for many years. We know that there are about 230 unique human milk oligosaccharides present in the breast milk. And in terms of size, they have anywhere between 3 to 32 sugars. And industry has been trying quite hard to somehow develop in the laboratory all the important human milk oligosaccharides. Over the last 30 or 40 years, hardly 3 or 4 they have been able to manufacture in the lab, and we'll go through them as we go to the slides. So just to classify the HMOs, there are 3 different types. Very simple to remember: fucosilated neutral, non-fucosilated neutral, and silated acidic HMOs as such. Fucosylation is basically attaching a simple molecule of fucose to the complex structure of the sugar to make it more effective and functional. Sialic acid, basically, as the name suggests, is when you add sialic acid to the complex existing sugar in the breast milk. Importance of fucose basically lies in the fact that it can line the gut epithelium and then, importantly, the immune cells in the body as such. So it's not a wonder that they are capable of acting as decoy receptors for pathogens, not allowing them to attach to the epithelial surface of the gut and various other surfaces. Importance of sialic acid is that it's an important element for development of the brain. So that is the reason overall, in terms of prevention of sepsis and development of the brain are the two physiologically important functions of HMOs. And indirectly, because human milk oligosaccharides being very complex sugars, the human babies don't have the enzyme structure to break them down. So then why do they exist in the breast milk? For the simple purpose that when they are capable of being not metabolized, they go down all the way to the colon, and where the bacteria which normally sits, they can metabolize these various sugars, and the metabolic products that they form are basically used as the substrate of the food by the beneficial bacteria which sit in the gut. So that is the reason human milk oligosaccharides, even though they are non-digestible, they are provided in the breast milk by nature so that they can be used as a substrate for the common cell bacteria in the gut, which in turn can break these sugars down. And the metabolic products are extremely beneficial for the human baby as such. And when we say beneficial, it basically means good bacteria like bifidobacteria in particular, which are most important in the infancy. They are capable of digesting these sugars and the metabolic products, especially short chain fatty acids, which are formed in the process, are very good for the gastrointestinal developmental health, maturity, and function. As we covered, in terms of which one is the most common, 2FL or 2-fucosyl lactose is the most common HMO present in the breast milk. If there's a predominant 2FL in the breast milk, the mom is identified as being a secretor mom. And the secretion of this particular HMO depends on a gene which is called as FUT gene, FUT, which is simply fucosyl lactose gene. So if the mom has got this gene, she will be able to secrete lots and lots of 2FL in the breast milk, which is important because of this function. And then that mom will be identified as a secretor mom. And we know for the last 30 years that the how much amount and what different types of HMOs the mom will have in the breast milk varies from mother to mother, varies from pregnancy to pregnancy, and importantly, varies from the region and the ethnicity where the mom comes from. And that is the important thing to know, because based on where the mom is residing, you would have a different fucosyl gene profile of the mother, and that will determine can she secrete the complex 200 types of HMOs in the breast milk for the benefit to her baby as such. The practical reason or practical applicability of this fact is if we can prospectively identify mothers, whether she's a secretor or a non-secretor, then in terms of looking in the future, we can have supplementation of the right kind of prebiotic oligosaccharide made up in the laboratory to give it to that mother so that her milk will have the correct combination to promote the good bacteria in that mom's baby as such. So this is what we call as what lies in the future in terms of designer prebiotics, because if we know what kind of probiotics we are giving as a supplementation to the mother who is non-secretor or secretor, then we can understand what kind of sugar basically is the best one to give it to her as a prebiotic so that there'll be lots and lots of bifidobacteria in that baby. So this is the so-called precision medicine in the future in neonatology. Sialylated HMO, as we know, that yes, sialic acid is quite unique. It helps in the development, maturation, and function of the brain and overall growth of the brain as such. And apart from that, it will also have the same effect like the other HMOs for promoting gut integrity, function, and development. And more important, it will keep the pathogens out by competing with the receptor sites, and it will not allow nasty bacteria like E. coli, Proteus, and Pseudomonas to come in and harm the baby. So that's the important reason why FL and SL are more important in terms of practical applications of prebiotics. In terms of our internationally agreed definition of what a prebiotic means, it's simply a substrate, which in this context basically is a complex sugar, which is selectively utilized by the bacteria sitting in the host gut to provide a health benefit to the host as such. Obviously, prebiotic oligosaccharides, normally when we use the term in day-to-day conversation, when we say prebiotic, which normally would mean a synthetically developed human milk oligosaccharide in the lab that we are using in place of HMO in case the mothers do not have enough of HMO in her breast milk, either because of her ethnicity, origin, and importantly, her secretor status. Secretor status determination has a good history that 60 years ago, it was understood that you can easily find out what is the Lewis phenotype antigen status of the mother by a simple test on the saliva. Because ultimately, secretor status, the word itself tells you that yes, can this mother or can this person secrete important enzymes or things in the body to protect the epithelial surfaces. When it comes to mother, it means ability of the mom to secrete human milk oligosaccharides. So this we have already covered, that when it comes to developing human milk oligosaccharides in the laboratory, so far only few of them are available. The commonest one that you would hear in the literature basically is something called as GOS-FOS, which is galactose oligosaccharide, which is a neutral short chain compound, or a long chain fructose oligosaccharide, which is called as fructose oligosaccharide, which is FOS. Most of the time you will get in the market a combination of GOS and FOS together. And sometimes you might have a pectin-derived acidic oligosaccharide available from the laboratory as such, but not much of literature is available in terms of clinical trials of these pectin-derived acidic oligosaccharides. Day on day, companies are trying more and more to add whatever is available as a synthetic human milk oligosaccharide, and they claim that this will give the benefit to the baby, just as if the mom did not have the capacity to secrete HMO, and now we are replacing for that. This is the evidence that will summarize currently where we are in terms of prebiotic use for preterm infant. So till date, as you could see at the bottom of the slide, only 18 small RCTs have been conducted. Total sample size is only 1,322. The commonly used prebiotics in the market in these trials basically are inulin, lactulose, galactose oligosaccharide, fructose oligosaccharide, and the pectin-derived acidic oligosaccharide. So if you check any so-called prebiotic product, you will see one of these ingredients as such. What we need to remember that many times the probiotic products will also contain these sugars, especially inulin and lactulose. But when they do the study, it gets published as a study of probiotic, when in fact it was a symbiotic because it has lactulose or inulin as an additional component. So in fact, which is a prebiotic. So the evidence so far shows, as you can see in this slide, that prebiotics can significantly reduce late onset sepsis, all-cause mortality, length of stay in the NICU, and time to full feeds. And you could see at the numbers which give the relative risk and the confidence interval in the bracket, they are relatively a good effect size. The confidence intervals are quite short. It means the findings are reasonably reliable. But important to note that when it comes to definite NEC, which is stage 2 and above, so far the data does not show that significant reduction in the incidence or risk of NEC after prebiotic supplement. You could see in the bracket that relative risk is 0.79. Yes, that means reduction in NEC by about 21%. But there is a possibility that it could be as high as 56% because one of the confidence interval number is 0.44. But unfortunately, the other number, the higher limit of the confidence interval is 1.44. It means there is a possibility that prebiotic can increase the risk of NEC. Now, when you deal with such uncertainty, you just need to ask yourself one question. Is there a biologic plausibility that yes, prebiotic can actually increase the risk of NEC? So far, that is not the case. So what this simply means that the evidence in terms of benefit of prebiotic for reducing the risk of NEC is currently uncertain. So we need to have large randomized controlled trial with NEC as the primary outcome to answer that question. And similarly, the surrogate marker feeding intolerance, again, you can see that yes, the confidence interval includes 1.45. That means the result is still uncertain. If you are a purist in evidence-based medicine, you will say, currently, there is no evidence that prebiotic helps for NEC and feed intolerance, but we need more research. If you are a reasonably wide open practitioner of evidence medicine, you will say, yes, I can see that the results do not show that the benefits of NEC or feed intolerance exist, but it does indicate the strong possibility that prebiotics may be able to reduce NEC and feed intolerance. So let's go for a big trial. So this is where the take-home message for people like us would be, if there are so many controversies about probiotics, why don't we have a large, definitive, randomized controlled trial of prebiotics and confirm whether prebiotics can have the same benefits like probiotics in terms of NEC, sepsis, length of stay, all-cause mortality, and time to full feeds. So far, the field of prebiotics simply has not advanced to that extent, probably because probiotic field has progressed so fast since 1999 that the industry has lagged behind. That now, if they come back and propose a large definitive trial of a prebiotic oligosaccharide, say inulin, lactulose, gosphos, or pectin use acidified OS, there'll be hardly any takers because everyone is obsessed towards probiotics. So the solution could be, if you are using a probiotic, you could say, we are happy to conduct a trial of synbiotics. That means I would go for a randomized control trial where the babies are randomized to probiotic with or without a prebiotic. So that could be a proper pragmatic approach to assess prebiotics properly in preterm infants. This is a reasonably recent paper from Frontiers. It shows what we already covered in the first slide, that based on the mother's secretal profile and the content of her breast milk, if we know which type of oligosaccharide she is lacking, we could supplement specifically that human oligosaccharide. We know that the most common one is 2-fucosyl lactose, which is 2FL, which is available commercially. People have been adding it to the formula as well. So if we know that commercially available 2FL and then 3FL as well as 6-silyl lactose and 3-silyl lactose, rather complicated terminology, but if you need to just remember them simply, just call them as 2FL, 3FL, 3SL, and 6SL. These are the synthetic oligosaccharide. If we know that the mother doesn't have it in her breast milk, we can make it as a designer food for the baby, as long as everything else is optimal in terms of prevention of sepsis, NEC, and feed intolerance. So challenges we already covered, that no matter how much biomedical engineers have advanced in the laboratory, still they cannot mimic nature, especially to make all 230 HMOs in the lab so that you will have a perfect replacement of all HMOs to be given to a baby. But I think the saving grace is because we know 2FL, 3FL, 3SL, and 6SL are the most common oligosaccharides, which so far we have been able to synthesize in the lab. It is reasonably okay to say that we can go fairly close, but not identical to breast milk when it comes to supplementing HMO. And obviously, these are reasonably complicated things to develop, especially to make them available as a bedside capsule. That yes, here is a combination of 2FL, 3FL, 3SL, and 6SL that you can give it to the baby and claim that don't care about the mother's secretor status. This baby has been given all proper oligosaccharides. So this is one interesting thing. DSNLT is basically something that has been shown to be a reasonable good marker in terms of diagnosis or prediction of NEC. DSLNT simply means disialyl L-nitrose tetroase. So it's another sialic acid type of oligosaccharide. But the good part is they have reported that there's a threshold of, say, 241 nanomoles per mil. If the total DSLN content of the breast milk is less than that, then the risk of developing NEC in the baby is quite high. So this is something simple, but as I rightly told you in the beginning, not every laboratory will have the ability to measure these levels. In fact, I think there are not more than 2 laboratories in the entire world where these levels can be measured. So this is far from reality for everyone else, including we in Australia. It's not possible to do that at the bedside, very expensive. And this is just a reminder that because that particular complex oligosaccharide, DSLNT, basically is responsible for a good balance where the gut bacteria in the preterm babies are dominated by good ones, which is bifidobacteria. And basically, they will also reduce the proportion of the bad bacteria, which we know as of today is basically gamma proteobacteria. enterobacteria, because if they are high, the risk of NEC is quite high. So this is all about prebiotic as such. I've on purpose left probiotics toward the end of the talk because we have heard a lot about probiotics and the controversy. So let's look at this new concept, which is becoming slightly more common these days. This is the statement, which is basically a definition of postbiotics. What do we call as a postbiotic? There was lots of controversy. So finally, ISAP, which is International Scientific Association for Probiotics and Prebiotics, they agreed to this particular definition. Basically, a postbiotic is a preparation of inanimate microorganisms and or any component of that microorganism that will give a benefit to the host. Because when we talk about probiotic, it means a live bacteria, which will give a benefit to the baby. But when it comes to postbiotic, it means anything that you prepare from the live bacteria, and that thing now doesn't have a live probiotic bacteria, that can be called as a postbiotic. And interestingly, as you see, so many things can be used as a postbiotics, which is basically the well-known metabolic products of probiotics that you can have available as a supplement for a premature baby. In fact, butyrate is currently available in the market as a postbiotic. Years ago, I think about 2007, I had actually ordered short-chain fatty acid like butyrate to be tried as a supplement to the preterm baby, which unfortunately the company closed down because of financial losses. You can take fractions of the bacteria which is dead, no longer live. Those fractions, because it has got DNA cell wall component, it can work as a postbiotic. You can develop functional proteins from a live bacteria. You can use secreted or extracellular polysaccharides from a live bacteria, use them as a postbiotic. You can destroy the live probiotic bacteria by using various mechanisms. Whatever is left behind, that can be used as a postbiotic. And in terms of the cell wall has got teichoic acid, peptidoglycans, different components of the cell wall of a live bacteria. They can be used as a postbiotic. And last but not the least, every probiotic bacteria has got the pili, or the so-called hair on the surface of the cell, which help the bacteria to attach to the cell surface in the gut. So those pili also are very much active metabolically. So even those pili type structures can be developed in the lab as a postbiotic. So there's a tremendous interest in development of postbiotics. Why? Because if we can avoid probiotics, we don't have to use a live probiotic microorganism. It means we get rid of the fear of probiotic induced or probiotic caused sepsis. We don't have the risk of antibiotic resistant development and spread. Importantly, the cost comes down. And most importantly, for people like us in India, we don't have the worry of shelf life and cold storage. The moment you talk about the cold storage, because some of the probiotic products, especially Infloram, which has got one lactobacillus and one bifidobacteria, the manufacturers will insist that this product has to be carried at minus 80 degree, at least minus 20, right from where it is developed in the laboratory to the point of care in the nursery. Unless it is stored at the right temperature, we don't guarantee that it will have the right numbers of live bacteria. Obviously, the cost of that product is quite high. So that's the reason that if you don't want the risk of probiotic sepsis, antibiotic resistance, short shelf life, and high cost, then the answer might lie in postbiotics. Then let's go for something called as ghostbiotic. What the clever scientists have done, they have literally preserved the wall of the live probiotic bacteria and sucked everything inside out. What is left behind is simply the skeleton of the probiotic bacteria. And no wonder it's called a ghost biotic as such. And because the remnant, the very well preserved cell wall of the microorganism, which is the probiotic bacteria most of the time, even that cell wall is more than enough to initiate the beneficial mechanisms to give you a benefit like a probiotic. So this is what is called as the ghost biotic as such. So basically, what are the mechanisms by which you can inactivate the probiotic bacteria, which is live? So basically, you can use heat or chemicals like formalin, or you can use ultrasound rays or gamma rays, or a process called as sonification. So basically, these are the different ways where the live probiotic bacteria is no longer live. It is completely inactivated, but it is not dead yet. Whatever the DNA and good things it can do being live, it can still do. And that is the reason, for purpose of simplicity and cost and logistics, mostly heat inactivation has been used now to make a preparation from a live probiotic bacteria so that it is no longer live, but it is still potentially useful. So that's the reason that this is the slide which covers what already I have told you about the potential benefits of postbiotic in a preterm baby, or in fact, for any immunocompromised patient where you want to give probiotic, but you're worried that it might create problem. For example, severely malnourished patients, patients who have got, say, HIV, or patients with cancer. So these are the people where the gut flora is completely destroyed. They are desperately need for something like probiotic for benefits of the developmental maturity and function, but you're worried. So in that case, that kind of population is potentially benefited by postbiotics. So it's a good topic for research. These are some of the very famous well-known references which finally indicate that lactobacillus and bifidobacterium species of bacteria, which is what we commonly use in preterm babies, are very much capable in their heat inactivated form to give benefits for premature baby. So these are some of the more recent references that I have quoted on the slides. Always happy to let you have a look at the slides and share anytime. I have no issues with that. Just having a look at this, one of the important and interesting slides, what is called the zombie probiotic. In about 2015, the clever scientists from Nestle, they reported that when a type of lactobacillus strain, which is Lactobacillus paracasei, NCC2641, is the specific identity of that particular lactobacillus. What they showed that when they heat treated this lactobacillus, in fact, it was like a zombie. It was not dead, it was not alive, but it was actually more beneficial. It was more capable of adhering to the gut surface compared to a live bacteria. And that is the reason this became another very important area, that heat inactivation might be a way to go in the future in case you are worried about so-called probiotic adverse effect. So keep that at the back of your mind, because heat inactivation is a very simple technique. In fact, if you are using heat or pasteurized human donor milk, there is no reason why we can't heat inactivate a probiotic bacteria. Modified probiotic is another word that our scientists have used. And this is basically a very good systematic review and meta-analysis of heat-killed or sonicated probiotic bacteria to prevent or treat diseases in human beings. 40 randomized control trial, can you imagine? 3,000, nearly 4,000 patients had studied. 14 trials where they use this kind of bacteria for prevention, and 26 trials basically for treatment of various diseases in human beings. And what they found, that in reality, modified microbiomes were actually as good. The language they have used is, they were not significantly more or significantly less effective compared to probiotic bacteria in 86% of prevention and 69% of treatment trials. So this current evidence definitely support that, yes, these type of trials are very much the need for future if you don't want to deal with live bacteria in any setup. So this is what we already covered. Overall, they say that whatever the data currently exists, from that there was a lot of material available, evidence available on Lactobacillus acidophilus. I have selected that particular bullet because Lactobacillus acidophilus type of strains we are quite familiar with when it comes to probiotic using preterm infant as such. This is the trial that we had just finished in our own unit in Perth, ProPara trial, where what we did basically, we did a pilot randomized control trial of comparing live versus heat inactivated probiotic for babies under 28 weeks of gestation, because that is the risk, that is the gestation which is at the highest risk of so-called NEC, sepsis, death, and delayed time to full feed. At the same time, highest risk of, say, translocation of the given probiotic bacteria across the gut epithelium and causing probiotic sepsis. These babies are also exposed to antibiotics quite frequently, no matter which part of the world you are. So they are at the risk of developing antibiotic resistance, and probiotic organisms might play a role in that. So that is the reason we said, let's try a pilot randomized controlled trial to be futuristic and find out whether live versus heat inactivated probiotic bacteria gives any significant difference. So what we found that everyone under 32, including those under 28 weeks, basically were eligible as long as they were not on enteral feed for more than 12 hours and we had the consent from the parents. This is important for us to look at. What we use basically a mixture of 3 bifidobacteria, because you will recall that most of the evidence currently shows that multi-strain or a mixture of probiotic may be more beneficial compared to a single probiotic bacteria. We were lucky that we have this product from Japan where we have single Bifidobacterium brevi M16 and the so-called champion colonizer of the gut, Bifidobacterium longum subspecies infantis, which simply is called as Bifidobacterium infantis. So there are different strains of Bifidobacterium infantis. What we have is B. infantis M63 and another famous bacteria in the preterm world, Bifidobacterium longum, subspecies longum, which is longum longum, very interesting term. Anyway, so we use 3 billion bacteria of this live 3 bacteria product and the same dose of the heat inactivated product to these babies. And you could see the method was so simple. Expose the culture tank of the probiotic to 90 degrees for 15 seconds, and all the bacteria are no longer live, and the product is ready for use. Primary outcome was safety. Important was fecal calprotectin level because that's the marker of gastrointestinal health, basically how much inflammation is there in the gut. And we had powered that study for fecal calprotectin level. And what we found basically that the product basically was tolerated well by the preterm babies, including those under 28 weeks. The reduction in the level of fecal calprotectin was equally good in both heat and inactivated as well as the live probiotic arm. So that is the product we plan to take it one step further as a definitely big randomized controlled trial of a heat inactivated mixture of probiotic compared to live mixture of probiotic. This slide I have just tried to give you a concise list of the controversies of probiotics that have been plaguing this field for last at least say 10 years. First thing is we don't believe in meta-analysis because all the probiotic strains are different. Each one is different, so each one needs to be tested separately before we can choose it for clinical use. The famous PIT trial from UK apparently showed no benefit of single-strain Bifidobacterium brevi from Yakult. Americans still say we don't have enough data from babies under 1 kilo. Some people worry probiotics might cause sepsis. Those who want to use, they say, oh, we don't have a high quality probiotic product in place where we practice. Those who are in Europe, they will say that if the baby is on breast milk feeds, we don't need probiotics. Some will say our incidence of NEC is very low, we don't need them. Some will worry that, oh, we don't know the long-term safety, whether it will cause any problem to neurodevelopment, growth, and immunological tolerance of the baby. And last but not the least, there are some devoted opponents of probiotics which say unless we have a definitive large trial in babies less than 1 kilo in North America, we are not going to accept it. So the answer to all this controversy as it stands today is there's absolutely no evidence to support any one of these controversies. The answers have been there for the last 10 years. So basically, it has simply become a school of believers and non-believers. Non-believers are around simply because of their strong belief, not because lack of evidence. To give you a simple example, a very famous paper in 2017 written by the reputed scientists of probiotics from ISAP, they have clearly shown that as long as we use bacteria from the genus Bifidobacterium and Lactobacillus, they share many different mechanisms of benefit. So it makes absolute sense to put the data together as long as the bacteria are from Bifidobacterium type and Lactobacillus types. So it takes away the objection to meta-analysis where you combine the data on these 2 common types of bacteria. Talking about no data on babies less than 1 kilo, you can check one of our publications. Data does exist on almost 4,000 babies less than 1 kilo to say that the benefits in this population are as good as benefits in babies between 1 to 1.5 kilo. There's no point in saying that breast milk is good. So if you're using breast milk, there's no NEC. If that was the case, the units where they use exclusively breast milk or a donor milk, they would never have seen necrotizing enterocolitis, which is not the case. So that is the reason that currently there's no time or place for any argument. This is what Barrington had reminded way back 10 years ago, that a randomized control trial of 2,000 babies with a baseline incidence of 8% would ironically have to show increase in incidence of NEC by 2 times to negate the current evidence. And such a reversal of benefit has never been shown in any field of medicine. Then he points out that a randomized control trial of 4,500 neonates at least will have to show no benefit at all in mortality to say that probiotics don't reduce the mortality in this population. So this is a very good statement from JAMA, written as interestingly by 3 people from the US. And they said, given the current evidence, this is their view, that additional studies basically will have to show no effect of any probiotics on NEC if we have to conduct a large trial of 80,000 infants. Now, you know, this kind of trial is just an imaginary thing. It's never going to happen, and especially for it to show no benefit of NEC. So the practical solution that they have given is, if you are a pragmatic clinician in the field, just accept the uncertainty and the current evidence, go ahead and start using routine use of probiotic. So I was quite happy with this statement coming from American authors in a prestigious journal at JAMA based on the current evidence. And it does make sense because, as I said, there's absolutely no evidence that all the controversies that I've showed in that slide have got any basis. They are completely baseless. I will say that again. There is no evidence that that controversy are actually applicable at the bedside. Symbiotics, that is pre plus probiotics, this is the evidence as it exists in 2022. As I said, not much evidence because only 6 small trials, together only 925 babies. Commonly, they have used lactobacillus or bifidobacteria or combination of 2 and combine them with the prebiotic synthetic, which is GOS, FOS, or both. Results basically, yes, symbiotics reduce NEC and mortality, but not late onset sepsis. Now, as I said, if you got less than 1,000 patients from 6 small RCTs, it simply means the evidence is so far inadequate. So you could go for a large RCT of symbiotic and find out whether they are much better compared to probiotic alone. And I think that's where I'll take a break and be happy to answer your questions. So we have covered prebiotics, postbiotics, symbiotics, and probiotics. And the net answer was basically get on with life, trust the evidence as a pragmatic clinician, start using probiotics. One thing I would just remind you, and I think Razak's comment in JAMA has given that beautifully, that don't blame probiotics if the risk of NEC doesn't go down, because what you need to have is many things in the right place for the whole thing to respond to probiotic. And what are they? In utero transfers, antenatal steroids, preferential early use of mom's breast milk, backup as donor human milk, everything in your just capacity to reduce the risk of late onset sepsis, stop misuse of antibiotic, have a standardized feeding protocol in place, have a proper approach to management of babies who have that so-called altered Dopplers and growth restriction. And we know it is difficult for a country, even like India, to conduct a randomized control trial with few thousand babies, considering our difficulties with regulatory agencies, availability of the product, so on and so forth. So unless all these products, policies and protocols are in place, probiotics alone will not be any magic as such. So that reality is beautifully pointed out in the JAMA viewpoint. So please have a look at that viewpoint in JAMA as well to get the big picture.
Thank you so much for that excellent lecture where you've taken us through everything related to pre-pro postbiotics. And I thank Abdul Razak as well for those comments, which really gives us confidence to many of the clinicians. We do have some queries. Some of that you might have answered already, but if you do not mind, I would repeat
Absolutely.
that
Go ahead.
first. Thank you. Uma Devi has raised hands. I mean, do you want to ask a question directly, Uma? You can be unmuted, Sonam.
Yes, sir. So, Uma Devi, if you want to ask your question, you can just unmute yourself and ask your question.
Yeah. Could you be precise and stick to the question, please? Yeah.
Mm. So I think we can take another questions
All
Sure.
by
right.
the time she unmute us.
Sure. In the Q&A, Dr. Vimal Kumar has the common question that we face in India. It's about concern regarding the probiotic strains, which are pan-drug resistant in the lab and are being used in the clinical practice for some time now. So, how do we? Because the strains which have been tested abroad are not available in India. What's your take on that? Should we continue to use that?
I think, to my knowledge, at least three or four probiotic products are available in India, which have got good quality of evidence to back them up. They have a good assurance from the manufacturer in the quality of the product that it does contain what is on the label and it does not contain what is not on the label, which is the second half is more important. As you know, the only case reported in the literature, especially it was the famous case from the US, where the baby who was a 29-weeker given a probiotic died from NEC on day 9 or day 10. And on autopsy, the entire gut was full with fungus, which was exactly the fungus coming from the probiotic bottle. That was the time when FDA issued a strict warning in the US and everyone got scared that you have to make sure that the probiotic product that you are using off the shelf from the market is a risky thing to do unless you have an on-site ability to check what is inside in the probiotic bottle. At least can you identify that, yes, there's a lactobacillus and I can see a bifidobacteria, and importantly, I don't see a fungus and I don't see nasty gram-negative antibiotic resistant bacteria. That's the least you could do. The three products that I have seen myself in India basically is M16V coming from Japan. I think I should not be taking the trade names as such, but I think it comes from the same company which provides the same bacteria to us in Perth for last 11 years. So that is something that I can certainly say that we have independent quality check of that product last 10 years, and it is absolutely top of the class. Similarly, Lactobacillus GG, LGG product, which is one of the most extensively studied, safe, high quality product that is available in India. And last but not the least, I think recently, L-Reuteri DSM 1790, the famous infant colic drops, probiotic drops. It is the same product that has been used for prevention of NEC. So these three products straight away come to my mind. And I think the local favorite in India, as I have seen in the literature, is something like the Bacillus chlorzi.
That's the one question.
So I think one of the centers in US or Pakistan, have a look at that paper. They have taken extra effort to find out that of all the products of Bacillus chlorzi available off the shelf in markets in India and Pakistan, which ones are reliable? And they have given the two trade names which they found had reasonably good quality in terms of the content and assurance that there's nothing nasty in that bottle. So I think there are at least 4 or 5, and I think the product Darolac, that's the name that I keep hearing in India.
That's the most commonly used.
That is the very prestigious company called as Lallemand from, I think, France. So that company is a reputed manufacturer of probiotic. So as a courtesy, if a clever microbiology person in Indian teaching hospitals, at least, if not corporate, if they can just confirm that it does contain whatever it is claimed on the in the product and nothing else nasty, that is again something that you could use, because the bottom line today, based on that famous paper, Shared Mechanisms of Probiotic Strains, they say as long as you are using anything which is like a lactobacillus and a bifidobacterium, specifically if it's in a combination, you are very well justified the probiotic, but do keep a track of the results after using that product, because that will be a simple, pragmatic approach. Because they have said, as long as these two combine together, you are entitled to say that, yes, they might give you the same probiotic benefit compared to other products from the clinical trials. So I'll say that again, M16V, Lactobacillus reuteri, LGG, Darolac, and Bacillus clausii. These are the 5 names that I have been hearing in India for the last 10, 15 years as such. So as long as your microbiology lab has assured you that, yes, these products do not contain anything nasty, for us in India, it means gram-negative, drug-resistant bacteria, and worst is fungus, because fungus will multiply rapidly in the probiotic product if it is not developed to the correct quality. Probiotic manufacturing plants basically do not allow anyone to enter the plant because they don't want any exposure to oxygen. They don't want any exposure to moisture, because when the product gets packed in the sachet or a vial or a bottle, they make sure there should be no moisture and no oxygen. Moment you open it, you allow the fungus to get in, and rest you know. If you are unlucky, then you end up developing a complication of probiotic. That's the reason.
Thank you. Thank you so much. But clearly the message is that needs to be checked in terms of what you're using and the reliability of it. And if it is obviously pan-drug resistance, then obviously you wouldn't advise that strain to be used. Yeah.
Okay. Ironically, you would want a probiotic bacteria which is resistant to antibiotic. Because if you are exposing the baby to antibiotic, the probiotic should help. But the answer to that is, most of the antibiotics, when you're giving them intravenous for a critically sick preterm infant, the intraluminal concentration of the antibiotics at the gut level is absolutely minimal compared to the dose of probiotics, which is 1 billion organisms continuously every day. So despite exposure to antibiotics, babies less than 28 weeks have still shown significant benefits of probiotics. And the other school of thought, which we must understand, is probiotic bacteria, yes, they are live, but 1/2 of the school of scientists have agreed, even if they're dead, they are still beneficial. So even if antibiotics are killing the probiotic that you are giving, as long as they're giving a big mass, like 1 billion, 3 billion every day, even if the antibiotics are destroying all the billions of probiotic bacteria, even when they're dead, as long as they pass through the system from the mouth all the way out in the feces, they will do their job because of their contents of the cell wall, the enzymes, and the metabolic products. Because this is the thing, we have been counting probiotic bifidobacterium and lacto in the fecal matter, and we talk about colonization. It is not colonization. Colonization is only if you do an intestinal biopsy to show this is where the whole mass is nicely hidden, multiplying, and they have set up a nice colony in the baby's gut. We simply count what you are giving from the top and coming out from the bottom. So that's not colonization, it's a surrogate marker, because if I check the fecal count, I will always get some bacteria because I'm giving it every day, 3 billion. So because of gut motility, they will be coming from the top, going out from the bottom. But they do their job in transit. That is how they work. And if you are good, they will adhere to the gut mucosa, sit there, multiply. That's when you could say the benefits are actually because of colonization as well, and not only because of their transient passage through the system. They can do their job as long as they are given a right to travel from the mouth all the way to the fecal matter.
Thank you so much. Thanks a lot. Now, Dr. Manasi Vakankar from Pravara Institute of Medical Sciences, Loni, is asking about the fundamental questions regarding probiotic, which you discussed about, discussed during your presentation and during your papers, which is safety and efficacy of probiotic administration in preterms, and if they are immunocompromised or have any congenital anomalies of the GIT, how does one get confidence to use it? In brief, can you tell us the role of pre and probiotic supplements in preventing NEC and preterm, which you did mention? How these missing links can be found? How does probiotic administration in very low birth weight reduces the incidence? So this again, the similar questions that you would be facing for more than a decade now.
Sure. So the one important question I think that I could answer if I got your message right is the paper that we have published, Systematic Review of Probiotic Sepsis in Preterm Infant. And it has shown beyond doubt that the risk is very rare and the benefits far outweigh probiotic sepsis. And probiotic sepsis is very easy to diagnose and treat because most of the probiotics, especially if they are the lacto and bifido type, they are extremely sensitive to simple antibiotics like penicillin, vancomycin, and so on and so forth. As long as your microbiology department can identify bifidobacteria in routine blood culture, you should be safe. Lactobacilli are easy to identify in the blood culture. Bifidobacteria need some adjustment of the blood culture medium. In our hospital, we use the simple, commonly used Bactec culture medium without any modification. And it can confidently detect bifidobacteria in blood culture within 3 to 5 days, which is the standard time. After 3 days, it is almost impossible that you will say, oh, now I can see some bifidobacteria. It doesn't happen that way. If it is there, Bactec culture medium can detect bifidobacterium sepsis within 72 hours. So if you can identify it so easily, if you can treat it so easily, no baby should die from probiotic sepsis. And that is what we covered in that very new paper, where I think one of my medical students is the first author, Kulkarni. So you can definitely trust on that paper. And that's what other people have agreed, that it's a rare phenomenon. Correct? But don't forget about the case that I just discussed with you about the fungus getting rampant in the bottle. Because India is basically hot and humid. And God forbid, if there's a probiotic bottle sitting at the bedside for too long, and if there was a contaminating fungal inside, you will be giving the baby a live fungus, which is exactly what happened to the 29-weeker in the US. And that is the reason Saccharomyces type of probiotics are best avoided. Because Saccharomyces type of probiotic basically comes mostly as a powder. And the moment you deal with powder, the droplets basically hang up in the air around the baby. And when the droplets settle down, they can easily contaminate lines, tubes, and catheters, including long lines. So one of the systematic reviews of probiotic sepsis, they give a good warning that be careful for hand washing and don't play with fungal type of probiotics, at least next to the baby. Get the dose ready-made in a syringe outside, give it to the feeding tube, hand washing, and then walk away. Don't keep moving that bottle around the nursery. It's a risky thing to do. So I would say go for lactobacillus and bifido type of mixture rather than Saccharomyces, which is a fungal antibiotic.
Dr. Mansi, so the message is that the quality of evidence regarding the effect, there is no kind of even discussion about it. There is proven benefit.
Yes.
The question is about the product quality, product preparation until the delivery into the baby and
Yes.
monitoring. So that chain will have to ensure that the quality is maintained. But
Correct.
once that's in the gut of the baby, they will do magic. Definitely, they would help. Definitely. Apart from looking at other aspects of prevention of the NEC, which all have to be 6-7 things that as a bundled care you can look at that.
Yeah. I'll give you a simple example. I had the license to import this Japanese product as well as Infloran, which is used around the world. I chose the Japanese products for 2 reasons. I proved over 2 years storage in my office at room temperature, the colony count was perfect. There was never any contaminant. And during the use, every year we have been monitoring the quality of random sachets of every stock that we buy. I did not go for Infloran because for Infloran to come all the way from Italy via Europe to Singapore to Perth, I have no guarantee of maintaining temperature at -degree by a dedicated cold chain courier. And the cost was high. So I said, I would rather go simply buy a product which can come by a simple air courier, doesn't require any fancy temperature logbook. And I have shown that in my own office, the stock maintains colony count for up to 18 to 20 months. So that is how, instead of having Infloran, we went for the Japanese product. So same thing you could do in India. that can I confirm that if I store this product in my unit and I ask my microbiologist, can you just make sure that there's no fungus after 10 months, 12 months, 24 months? Then I know it's a good quality product. Or the other solution is don't use any product for too long. Use it and buy a new stock. And hand washing, most important.
Getting the basics right. Thank you. There's a question from Dr. Vikram Datta. I'm not sure whether he's in a position to unmute and ask. It's about going before the prebiotic itself in terms of a maternal, vaginal douche. If the probiotics are used there, then we reduce the neonatal sepsis in preterm neonates. This is colonizing the vaginal flora with the probiotics and the impact on the early onset sepsis.
Correct. If you read the Cochrane Systematic Review, where Dr. Roger Saul is one of the co-authors, they have covered everything about prenatal and use of probiotics to prevent preterm birth. And you are hoping that if the mother gets colonized, the baby will get colonized and the baby will have benefits of probiotics. But so far, there's not much evidence to that. Not much. People have tried even for prevention of allergic or atopic conditions in preterm babies in the long run. Correct? That is David Osborne from Sydney. So that never took off because it's like a long shot. Because orally we are giving 3 billion bacteria or 1 billion at least to the actual baby after delivery. If we give the higher dose to the mother, no one has studied how much is the colonization of the preterm baby when the baby comes out, or even a low birth weight baby. For example, 2 kilo baby born to a typical mom in India who has been on probiotic supplementation, hoping that she will get the benefit and the baby will get the benefit. But there's hardly any proof to that. Prevention of group B streptococcus colonization or bacterial vaginosis. These are the two fairly common conditions where probiotics have shown some potential. But I learned, I think, a couple of years ago that GBS is not a major problem in India. We have gram-negative sepsis as our main problem.
Yeah,
So,
I mean, the challenges with that again are because
yes,
the screening is patchy and as well as the extensive use of
correct,
antibiotics,
correct.
which might have killed the
Yes,
GBS.
absolutely. Yeah, with antibiotic misuse or overuse, we shifted from gram-positive to gram-negative bacteria. So GBS prevention is not the idea. Another area available for probiotic research in the mother is prolonged rupture of membranes. That is something that requires more attention. Otherwise, there's tons and tons of literature on maternal diabetes and hoping that you would prevent obesity or infants of diabetic moms who are 4 kilos. But again, not much evidence so far. It's not easy to overcome what is done by nature. Yeah.
Thank you so much. And there are no more questions. And I think we now 1 hour since we started the program. Generally, we stick to the timings as such. And we really appreciate your time and patience to go through the questions and explain in detail. There are no questions, Sonam. There are no other questions, right? I'm not missing anybody. From our end, from NQCN, we promote the filling the gap between what is known and what is practiced. So that's essentially this. The science has been established that probiotics are useful, but the gap is that we don't consistently use it or don't use it as per the guidelines. So we need to go back and look at quality improvement as a bundled approach or specifically for the probiotic. And look at improving our practices to get better outcomes. And we should start documenting our own data as such. We thank you, everyone. And you can give us a feedback by using that link. Thank you so much, Dr. Patole, for your valuable time, to spend this evening with us.
You're welcome. Thank you to everyone in the team. And thanks for the audience. Thank you. Take care.